Hi, and welcome to Dealing with Verification Data Overload. My name's Shelley, and I want to thank my talented co-presenters, Renfei and Lan, for joining me. This is a story about our work in several open source projects and our approach to dealing with massive amounts of verification data. As you can see, we'll cover a lot in the next few minutes, so let me dive right into the scope and the overview sections. Our work spans many open source projects, notably Eclipse Aquavit, which is the center of much of the work we're talking about today. And from that center, a lot of different activities unfold across projects and companies using the products of the Aquavit project. These activities relate to verifying software and ultimately ensuring that JDK binaries are tested and pass a certain quality bar before eventually getting distributed out to the world. In fact, since we started our work in the open 4 years ago, we went from having no distribution and 0 downloads to over 330 million downloads and counting. We have always cared about ensuring the quality of the binaries we produce, and having this many consumers allows us to feel the gravity of our work, the great weight of responsibility. When we look at our efforts, we see that the combination of tests that we execute quickly adds up to a whole lot of test of verification data. By the number of distributions, platforms, implementations, versions, and the actual sheer number of tests that we run, it builds up very quickly in a nightly build. We both gathered useful tests from various key open source stacks, accepted contributions of tests from various distributors, and we also wrote tests to fill in the gaps to ensure that we had satisfactory coverage of all the various aspects of the software under test. Plus, we categorized these tests into logical groups. Of course, Java is over 25 years old, and useful tests come from various eras and projects. And one thing is clear: everyone wants to write their own test frameworks. No one wants to use an existing one. So in the course of our test curation, we encounter a dozen different test frameworks, each with their own quirky gotchas and command lines for execution, different methods for test exclusion, often not producing standardized forms of test output, and often lacking in good documentation. But let me change gears for a moment. How did we arrive at gathering and writing of tests to cover particular enterprise-grade quality criteria? So that 4 years ago, we assessed the landscape and saw that there was some open source test material from the OpenJDK project, and there were some closed compliance test material under license from Oracle. And whatever distributors were doing behind the closed doors of their company was unknown. So we created a roadmap, which we're still working on today. It's important to clarify something here because there often seems to be confusion on the topic. TCK, those compliance tests that check that a binary conforms to the Java specification, and Aqua, tests for quality, are two very different things that serve very different purposes and are handled quite differently. Because of the license agreement that says things must stay closed and private, the project we work and run TCKs under is a closed project called Eclipse Tamarind Compliance. And of course, Aqua is the Aquavit project, and it's open source and available to all. But you can consider these two types of testing complementary, but very distinctly different from each other. So we've emphasized the importance of us being open and transparent, and there are a few other rules that we live by in the project. We have this diverse and robust set of test suites. We believe strongly that tests should evolve alongside the things that they are testing, so we continuously invest in our work and our tests. We have a process to modify the suite, and we run metrics to continuously check that tests are still valid and still useful in our work. And finally, we do also apply comparative analysis. We are very fortunate that we created something that can be used by many distributions and many implementations. So we can then compare test results across them, and that actually helps us improve the test material. We also wanted things to be portable, so a developer could run tests on her laptop, or we could run things in different CI systems. And finally, the importance of tagging and publishing material. It allows us to have a reproducible test environment. So this really just summarizes what I've already said. The key to remember here is the VEAT in the AquaVEAT project name stands for vitality. And it's our reminder to ensure that our activities stay vital. We create tools to actively help us in our tasks, like the release dashboard, which will be demoed shortly. And most importantly, we design for broad usage and adoption. And on the note of adoption, we come to our AquaVEAT certification story and the Adoptium marketplace. Our working group at Eclipse Adoptium has members who themselves produce JDK builds. And we are lifting up the notion of an Adoptium marketplace as a value-added service for consumers. The 3 criteria that one must meet to list their distributions in the marketplace: you must be a member of the working group and participate at the project. The binaries that you list in the marketplace must have passed both the TCK and the rigorous Aqua test suite. So when consumers come to the marketplace to pick up a binary to feed into their software supply chain, they can have a confidence in those binaries. So now I'll pass it over to Renfei to talk about the details of us dealing with such a massive scale endeavor.
Thanks, Shelley, for sharing the scope and overview of our project. My name is Renfei. I will be talking about the test framework that we have developed. As we are dealing with the overloaded testing and a large degree of complexity, we really need a reactive system which works well for our goal. It should cover the latitude of tests that use significantly different test frameworks. It should have the flexibility to specify and test against different requirements. It should have a common way to easily add, group, exclude, and execute tests. The test results should also have the same look and feel. And the last but not the least, it needs to be simple to integrate with any build system. As Shelley has talked, we need to categorize the massive amount of tests into different levels of granularities. The system should allow us to specify test cases names and test case groups, such as the functional system and so on. And we should be able to specify different levels, such as sanity, extended, and special. These levels can reflect the importance of the test and also related to the test duration. And we should also be able to specify different JDK version, different JDK distributions, and different test iterations, and the test on different JDK features such as AOT and so on. And we will also need to specify the test with native image or not. As you can see, our scope is quite large and complex, but our solution is simple. It is a test framework called TestKgen. We often call it TKG for short. It can be viewed as a mid-layer that consolidates and curates different test materials and makes them a common feel to the developers. We use an XML file called playlist to define different test targets. Each test folder has a playlist. It captures all test metadata such as test name, group, level, JDK implementations, versions, and so on. By using these test metadata, we are able to exclude, execute tests in different granularity. For example, to run a group of tests in OpenJDK, or we can split the OpenJDK group even further to different levels, such as sanity.openjdk, or we can run a specific test target. Or even further, we can define a custom target environment variable and run a specific test case. TKG can integrate with different CI systems. This is the pipeline of our workflow. We first build JDK images on different platforms, And then we send the images into the testing stage. In the testing stage, the different groups of tests are running in parallel. Even further, we have a dynamic parallel feature in TKG to split test group based on the test workload. So each group is evenly distributed onto different machines in parallel as well. And in the end, we go to the deployment stage. And if the stage fails, the next stage will be aborted. One of our CI systems as an example is Jenkins. We are using this centralized Jenkins file base for all test builds in Jenkins, such as nightly pull request builds and so on. And this script can be found in the Adoptium Aqua test repo. This is a snapshot of different builds we are running in Jenkins. It can be found in the ci.adoptopenjdk.net website, and these tests built are categorized based on JDK version and other JDK information. The TKG can generate different test outputs, such as type output and JUnit output. They are all standardized for different test materials. We also leverage third-party Jenkins plugins, such as Tab plugin, to show these test output in the build page. We also archive the test data from failed tests onto Jenkins master or Artifactory. Artifactory is a binary repository which we use to store test logs or long test output files or large diagnostic files, and also the tab file, JUnit file, and so on. Now I'm gonna pass on to my colleague Lan. She will talk about the upper layers of our solution. So Lan?
Yeah.
Yeah.
Can you hear me? Can you hear me? Am I muted?
I hear you.
Okay.
Yeah.
Let me just continue. Thanks, Renfei, for introducing the TKG and Jenkins CI pipeline. If you look this from a higher point of view, you will see 3 layers. We call this 3-layer cake. So the bottom layer is TKG, which, as Renfei described, give us a standardized way of running the test and exclude test. Also provides a standard way of generating the summary report. It allowed us to slice and dice run tests with different granularities. The second layer is CI system. We mainly use Jenkins, but we also use GitHub Actions and Azure DevOps. This layer is mainly responsible for scheduling the build and providing the base GUI. It runs the TKG commands to run all different tests. The last layer, which is the top layer, that's test result summary service, TISS. This layer needs the first layer and the second layer to work together. We will talk more into details as how this layer will help us to deal with the verification data overload. TISS monitor multiple CI servers, and it also provides filtering, sorting, comparing, searching features. It also gives us the history for triaging and performance trends. So all those features are purposely added so we can remove the noise for the people that triage in the build so they can get to the root cause quickly. We have a public TISS server, which we will demo shortly, and the source code is at the public GitHub repo. This is a quick overview of TISS, where we have the MongoDB database and React and Node.js. We have, in the server side, we have a backend worker, which are responsible for getting the data from Jenkins, inserting the data into the database. We also have a front worker, which is responsible for the client request and fetching the data from MongoDB. let's jump into the demo. This is our public TISS server. For this presentation, we'll only focus on the features that will help us to deal with the verification data overload. So let's dive into the grid view, which is an overview that allows people to see what pass or fail in a particular build. On this grid view, you will see different JVM distributions as well as different platforms. User can choose what platform they care about and just narrow down to the ones that they're interested in. Also, if you look into details, the first row is the sanity level, and the second row is extended, and then the third is special. And then we have different group tests, external, functional, OpenJDK, perf, and system. To match with the CI server result, the green means all the tests are passed, there's no problems. The yellow ones means there's test is completed, but there's some test failures that people need to look at. The red one means there's build problems. The one that grayed out meaning we didn't trigger the build. So from this, we can quickly know, say, for example, sanity.openjdk passed on ARM, but failed on ARM, but passed on PBC LE. Also, you can click into it to see more details as in what tests are running in this particular build. Click on the failed will actually lead you to the console output of the test, which people can dive into further analyze of why there's a failure. Also, we provide different actions for user to take. So all platform will show how the test pass or fail on different platforms, just in case if this issue is platform specific. In this case, the test passed almost on all other platforms except Spark, Solaris, and Arch. And also we have this deep history that shows the history of this test. So in the event, well, if the test is intermittent failure, then will be easily to spot out. The third action is possible issues, which is my personal favorite. This one actually searches the test across different Git repository and then find the matching issues with this test. With the quick glance, you know, oh, maybe this issue is already opened, then you don't need to open a new issue. Also, we have machine learning results incorporate into this page, so we will post likelihood of this issue related to this particular failures. And we have another feature called create new issue. So this one will basically gathering all the information for the user so they don't need to manually gathering the information such as test name, link to Jenkins, link to TISS or Java-version output, or even rerunning Grinder. So with the standard information collected, the people who get assigned with this issue can quickly work on the fix of this. The last is the link to Jenkins. So just in case if people wants to, look into more details and going back to the Jenkins runs. We also added like sorting features just for people to quickly find in the test, also searching. So if I search for JIT, and that will match with the JIT test. Sorting on different columns such as durations, you will know who is the longest running test. And then as well as the search feature. So if I search for exception, what does this do is basically searching for console to match with the test. This is particularly useful if you want to search for a particular failures that's happened, and then you want to know, oh, did any other tests are having this problem? So you can use that feature. And the last but not least, I'm gonna talk about the compare feature. So in the compare feature, what you can do is compare the pass runs and fail runs, and then look at what is the difference. So on my left is the failed runs, on my right is the pass runs. And we can further reduce this timestamp because that's a noise. To me, I only care about what is the difference in terms of the console output. And I can remove that and then look into what actually is different. And then people can quickly narrow down to the actual issue. We have a lot of performance benchmark features, but I'm not going to talk about that in this presentation. What I want to mention quickly is the dashboard. So it shows the performance trend, and then you can pick whatever values that you're interested in. And also this dashboard is highly customizable, so you can add whatever widget that you're interested. So that is the demo for the TRSS. We purposely add those features so this can help the user to narrow down to the root cause. So far, we have talked about the key approaches that we have taken to handle the large amount of verification data. To be honest, there's no real end to this work. We have continuously evolving and improving and to employ new and relevant technology. Ultimately, the goal of our data refinery effort is to display the results efficiently, allow user quickly narrow down to the problems, and better monitor the farm for supporting the complex continuous delivery pipelines. So on this slide, we have just the highlights of our future plans. We haven't listed everything, and some of them are work in progress. As we have more and more tests, we do need to test smarter and more efficiently. Can we increase the test coverage and catch more defects without increased test execution time? This is a question that we often ask ourselves. Dynamic compilation, change-based testing, bug prediction service, all three projects are working towards this goal. Also, with quarterly releases, we really need to make sure our test builds are reproducible. This will allow us to rerun exact the same set of tests against any JVM. We want to enhance TRSS with analytics service like core analytics and machine learning. We will continue to innovate and collaborate with data scientists to build machine learning skills and to refine our model. Last but not least, leverage and deploy useful models in open projects. So it has been a long journey for us. We have accomplished a lot during the past 4 years, but we still have a lot of work to do. We would really appreciate helps from all perspective of software development cycle, Java development, web development, UX design, machine learning, testing, triaging, documentation, and project advocacy. So please come and join us. And this is just our Twitter handle and reference to our project and Git repository. And that concludes the presentation. Thank you very much.
All right, I think we're here in the question and answer period. And I see that we do have a question. How tied are the software to the specifics of the Adoptium and OpenJ9 projects? And would that make sense to use for other most likely simpler projects? And I do want to say we have an example already of other projects using some of the tools that was shown just now. TRSS, for example, is very generic, and it's designed to be able to monitor any multiple Jenkins servers, and designed for you to be able to easily add plugin parsers for different types of test output. So we know of a Node.js team that's using it to monitor perf test results, for example, in their work. So we tried to create things in a generic way, but of course there are some modifications that probably would have to be done to adjust to something that's smaller or simpler. Maybe not in TRSS though. I think it's pretty easily ported to used in other places. All right, and then I have another question about how long does it take to run aqua tests? And I'll say the last time we checked, I can let other people jump in here too, by the way, Len and Renfei, but I'll answer the two that I see. The last time we checked, for every hour it takes to compile, for every hour of build time that we have at a project, we run 17 hours of aqua testing. And that obviously varies depending on what platform you're on. And we can parallelize that if we have multiple machines to bring that down to, an hour or two if we really have the machines for it. All right, some more questions. Are you using combinatorial test optimization techniques? Aha, good, great question. And yes, we have used that across some of the projects that we've worked in. And that's the notion of taking a look at the inputs and applying some matrix math and reducing the number of tests that we need to run to get a pairwise or three-way amount of testing. In particular, in the Eclipse OMR project, when we designed the low-level tests for that project, we heavily applied that technique. How easy is it for you with that great tool to judge whether tests are really broken by changes or just flaky? Hey, Lan, do you want to answer that one?
That's a hard one. We try to eliminate noise as much as possible. So there's a couple of techniques we're trying to do. For example, rerun the test, right? So there's a rerun link in Grinder link that we provide so that people can actually click a link, rerun it with different iteration, just to make sure that this test the failure is not intermittent. So we're actually building tools to help people on that end.
Yeah, and I'll say that there's some of the things that you demoed, Lan, that I use all the time. So that view where we showed, I think it was deep history, also shows the machines things we're running on. And you can very quickly see if there's a machine-specific problem, for example, where it's only ever failing when it hits a certain machine. And you can see things quite quickly from the different views, although I think there's obviously room for improvement. And in this talk, we haven't talked at all about our playful experiments with machine learning and how we're trying to train models to look for those flaky things. And if we find them, we'd like to fix or remove those tests, but it isn't always possible to do that without leaving a bit of a gap. So we need to sometimes replace tests that are flaky with something more solid, but the team is not large that's working on these projects. Yeah. Let's see if we can find any other. Oh, there was a question that I wanted to be able to answer that I figured no one would ask, but I'm still going to ask it, which is how do we manage technical debt at this large project? And I'm going to put my colleagues on the spot to see how they would answer that question.
Wow. Well, I guess every company has its own technical debt, and it's really hard to handle. I have to say, we're still handling it. But I think with the small team, we will always look at what will be the greater benefit in the long run, rather just give a patch to a problem. We'll try to get to the root cause, try to step back and say, oh, okay, why we're doing this? What's the reason? How we solve this so we can benefit us in the future? So we don't need to come back and fix this. So that's yeah.
Yep. And I think that might conclude the amount of time we have for Q&A. But thanks for joining us, and you can find us on those links that Lan already shared.
Thank you.